We've talked about two main characteristics of inhibition, that is reversibility and allosteric regulation. Now we will talk about the main types of enzyme inhibition: competitive, non-competitive, and uncompetitive. Let's talk about competitive inhibition first. Competitive inhibition occurs when the binding of the inhibitor prevents the binding of the substrate, and vice versa. This means that the inhibitors and the substrate have to compete for enzymes to bind to. It is a common misunderstanding about competitive inhibition that the inhibitor must bear structural resemblance to the substrate, and hence it can fit in the enzyme's active site and hence compete with the substrate for the active site. This is not true of all competitive inhibitions. Competitive inhibition can also occur through the binding of a large inhibitor to an allosteric site which blocks the active site, as we have gone through in the previous checkpoint. The active site is blocked, though it is not bound to the inhibitor, but nonetheless it is still a competition for the enzyme. So is it reversible or irreversible binding? Again, we usually only consider reversible binding because irreversible binding gives the inhibitor an unfair advantage in this competition. All the inhibitor needs to do is to form one bond and it wins the competition. Really, permanently, I don't think we can call this a competition of any sort. So how is the rate of reaction then affected by competitive inhibition? Since the rate of reaction is determined by the rate of formation of enzyme-substrate complexes, binding of competitive inhibitors reduces the availability of enzyme active site, reducing the formation of enzyme-substrate complexes and eventually reducing the rate of reaction. What we will see on the graph of reaction rate against substrate concentration is that of a less steep gradient. The Km increases as the affinity of the substrate to the enzyme is decreased. Competitive inhibition can be overcome by increasing substrate concentration because this increases the chances of the enzyme colliding with the substrate instead of the inhibitor. Or in other words, the substrate outcompetes the inhibitor for the enzyme. Therefore, eventually, the graph will plateau at the same rate.